For a derivative to exist, in other words, for a function to be differentiable at a point, a derivative as you get infinitely close to that point from the left and the right need to be the same. So in other words, here's point P. Think about the derivatives if you were just slightly to the left of 1 or slightly to the right of x equals 1. An instantaneous rate of change, the derivative at a point in other words, right here at x equals 1 looks to be about positive 1, and it is because it's y equals x. It's going up by 1 to the right by 1. A derivative slightly to the right using this function, that means we're going to have a slope of, it looks like maybe negative 1. Okay, so the derivatives are not the same, therefore it is not differentiable at point P. Okay, so to show that, you'd want to evaluate the derivative of both sides. You'd want to find the instantaneous rate of change of this function, and look, it's always a constant 1 if it's a straight line, right? So we know the slope from the left, so it doesn't show the slope approaching x equals 1 from the left is 1. And then the slope approaching x equals 1 from the right is negative 1. Okay, if we haven't talked about it yet, there's an easier way of finding instantaneous rate of changes, finding derivatives. But at this point in the course, all we have is the limit notation for the derivative. So we could use this one where it's the limit as h approaches 0 for f of, this is at location 1, so it's 1 plus h minus f of 1 divided by h. And then if you compute that for this function, you're going to get out negative 1. So that's how you could show that it's not differentiable at point P, because the derivatives from the left and the right are not the same. Okay, so same thing for this one. Look, this is a constant y equals 2. That means the slopes are not changing. Okay, not just that the slope isn't changing, but the y values are not changing either. Remember, slope is an instantaneous rate of change is a slope at a point, right? So the slope at any point here, you rise 0, run to the right 1. Rise 0, run to the right 1. So the slope from the left, the slope as x approaches 1 from the left is 0. There is no change. It's always a constant 2. But the y values are constant 2. For this one over here, the slope is 2. So the slope as x approaches 1 from the right is 2. Every tangent line you graph is going to have a slope of 2. So that's why it's not differentiable at point P, because the slopes from the left and the right are not the same.